Have you ever wondered what happens inside your body in the minutes and hours after you consume something sweet? What appears to be a simple bite of food sets off a highly coordinated physiological process involving your digestive system, bloodstream, pancreas, liver, muscles, and other tissues. As carbohydrates are digested, they are broken down into glucose, an essential source of energy for many cells in the body. Once glucose enters the bloodstream, your body must carefully regulate its concentration. This is where insulin, a hormone produced by the pancreas, becomes particularly important. But what happens to that glucose after it enters your blood? How does it reach your cells? And what happens when your body receives more glucose than it immediately needs? In this video, we will follow the journey of glucose through the body, from digestion and absorption to insulin release, cellular uptake, and energy storage, and examine how this process changes when excessive amounts of added sugar become a regular part of the diet. The journey begins in the digestive system. When you consume foods containing carbohydrates, digestion starts in the mouth, where enzymes and saliva begin breaking down starches. The food then passes through the esophagus into the stomach, before moving into the small intestine. Most carbohydrate digestion and glucose absorption take place in the small intestine. Here, digestive enzymes break complex carbohydrates down into simpler molecules, including glucose. The glucose is then transported across the intestinal lining and enters the bloodstream. At this point, the body must carefully regulate the rising concentration of glucose in the blood, because maintaining blood glucose within a healthy range is essential for normal physiological function. Once glucose enters the bloodstream, its concentration begins to rise. Because glucose is an important source of energy, the body has mechanisms that carefully regulate its level in the blood. One of the key organs involved in this process is the pancreas. Specialized cells within the pancreas, known as beta cells, detect the increase in blood glucose and respond by releasing insulin into the circulation. Insulin acts as a chemical messenger, signaling tissues throughout the body to take up and use glucose. This response helps move glucose out of the bloodstream and into cells, where it can be used to produce energy or stored for later use. The coordinated release of insulin is therefore essential for maintaining blood glucose within a healthy range after a meal. Not all of the glucose entering your bloodstream is used immediately. Once the body has met its immediate energy requirements, some of the remaining glucose can be stored for later use. The liver and skeletal muscles store glucose in the form of glycogen, creating an accessible energy reserve that can be mobilized when needed. However, the body has a limited capacity to store glycogen. When energy intake consistently exceeds the body's needs, excess energy can also contribute to the storage of fat. This is one reason why the overall amount and frequency of added sugar consumed as part of the diet matter. The effect is not determined by a single sweet meal, but by the overall pattern of dietary intake, energy balance, and physical activity over time. Once insulin is released into the bloodstream, it acts as a chemical messenger, signaling many cells throughout the body to take up glucose. In particular, muscle and fat cells respond to insulin by increasing the movement of glucose transporters to their cell surface. These transporters allow glucose to move from the bloodstream into the cells, where it can be used to produce energy or stored for later use. The liver also responds to insulin by taking up glucose and converting some of it into glycogen, a stored form of glucose. Through these coordinated actions, insulin helps reduce the amount of glucose circulating in the blood after a meal and supports the body in maintaining a stable internal environment. A single sweet meal does not automatically cause disease. The concern arises when foods and drinks high in added sugar become a regular part of the diet, especially when they contribute more calories than the body requires. Over time, consistently high energy intake can contribute to excess body weight and increased body fat. Frequent intake of sugar-sweetened foods and beverages is also associated with a higher risk of health problems, including type 2 diabetes and cardiovascular disease. It is important to understand that these conditions do not develop simply because someone ate sugar once or because of one particular food. They usually result from multiple interacting factors, including genetics, overall diet, physical activity, body composition, sleep, and other aspects of health. The key message is therefore not to fear sugar, but to understand moderation and the importance of an overall balanced diet. The goal is not to eliminate sugar completely, but to maintain a balanced and sustainable dietary pattern. Particular attention should be given to foods and beverages high in added sugars, especially when they are consumed frequently or in large quantities. A healthier approach includes choosing nutrient-dense foods more often, such as vegetables, fruits, whole grains, legumes, and appropriate sources of protein, while limiting excessive intake of sugar-sweetened beverages and highly processed foods. Regular physical activity also supports healthy glucose regulation and overall metabolic health. As we have seen, blood glucose regulation is a coordinated physiological process involving the digestive system, pancreas, liver, muscles, and other tissues. Understanding this process allows us to make more informed decisions about our nutrition and long-term health. The important message is simple. Your body is constantly working to maintain balance. What matters most is not one sweet meal, but your overall dietary pattern and lifestyle over time. For more clear, evidence-based health education, subscribe to Health with a Zen.